Hi, here in this question we have a boat takes 2 hours to travel downstream a river from A to B and 3 hours to return back. So we have point A upstream and point B downstream. So a boat takes 2 hours to go down and 3 hours to come back. Okay, 2 hours and 3 hours. So the first boat takes a total of 5 hours to go from A to B and then come back. There is another boat which takes a total of 6 hours to travel from B to A. So now it goes from B to A and then comes back, and it takes a total of 6 hours. So it's pretty much the same thing. Here also the boat is traveling twice between A and B, one way and the other way. Here also the boat is traveling twice between A and B, one way and the other way. So from both these cases we can say that this boat is the faster boat as it is covering the to and fro distance in just 5 hours, and this is the slower boat because it is covering the whole distance in 6 hours, which is greater than the total distance, the total time over here. So this is the slower boat and this is the faster boat. Okay. Now let us assume that the distance between A and B is a number which is divisible by 2, 3 and 6 as well. So let's take a very simple number, 12 kilometers. Okay, let's take it as 12 kilometers. Now you can simply assume a variable x or d and solve it accordingly. Even that will give you the correct answer, but that will involve a variable which cannot be simplified, so you'll have to do some calculation there. In terms of fractions, there will be a lot of fractions there. So to avoid that fractions and calculations, I'm assuming a simple number, 12 kilometers. Okay. Now considering the faster boat, what is the upstream speed for the faster boat? Let's see. The upstream speed will be the speed of the faster boat minus the speed of the river, F minus R, and this speed will be the distance of 12 kilometers is covered in 3 hours while going upstream. So the upstream speed should be 12 by 3, which is 4. So F minus R is 4. So when the boat is trying to go from B to A, the upstream speed will be the speed of the boat itself minus the speed of the river, which should come out to be 4 kilometers per hour. Distance of 12 is covered in 3 hours, so speed is 4 kilometers per hour. Similarly, downstream speed will be F plus R, this we already know, and this downstream distance of 12 kilometers is covered in just 2 hours. So downstream speed will be 12 by 2, 6. So solving these two, F comes out to be 5 and R comes out to be 1. So speed of faster boat is 5 and speed of the river is 1 over here. Okay. Now let's do the same thing for slower boat, but for slower boat we don't have a breakup of downstream time and the upstream time. So we'll have to make a single equation. The time taken to go downstream will be 12 upon s plus 1, where s is the speed of the slower boat and 1 is the speed of the river that we have already got. So speed while going downstream will be s plus 1, so time taken will be 12 upon s plus 1. And the time taken to come up will be 12 upon s minus 1. Distance is 12 and the speed will be speed of the slower boat minus 1. So this is the total time taken, which in the question is given to us as 6. Okay. So 12 gets cancelled out with 6. We have 1 remaining and 2 remaining over here. Taking 2 out common, we have 1 upon s plus 1 plus 1 upon s minus 1 is equal to 1 over here. Okay. So you have twice of s, taking LCM of these two, s minus 1 plus s plus 1 upon s plus 1 into s minus 1 is s square minus 1 square, which is 1. So we have twice of minus 1 plus 1 cancels out, twice of 2s is equal to, this gets multiplied here, s square minus 1. So taking this on the right hand side, this becomes s square minus 4s minus 1 is 0. Okay. And once you solve this is basically a quadratic. It's difficult to factorize this, so it's best to use the formula method here. The value of s comes out to be minus b, which is 4, plus minus square root of b square minus 4 times of 1 into minus 1. So that becomes plus 4 upon twice of a, which is 2. So this is 4 plus minus square root of 20 by 2. So this becomes 4 plus minus square root of 20 is effectively 2 root 5 by 2, and this gives us 2 plus minus root of 5. Now obviously root 5 is greater than 2. So we cannot have minus 2 minus root 5 because that will give us negative value of speed. That's not possible. So minus root 5 is rejected. The only possible value of speed is 2 plus root 5. So s is equal to 2 plus root 5 here. Okay. And now finally coming to the question that is asked. The question is, if the speeds of boats and rivers are constant, fine, then the time in hours taken by the slower boat to travel from A to B. So to go from A to B, what is the time taken by the slower boat? So to go from A to B, it means the boat has to go downstream. So time taken by slower boat to go downstream will be the distance between the 2 points 12 upon speed while going downstream. Speed while going downstream will be s plus 1. S plus 1 is effectively 3 plus root 5. This is the time taken to go downstream. Now since there is no option in this form, let's rationalize this. We can rationalize the denominator by multiplying and dividing the whole expression with 3 minus root 5, the conjugate of 3 plus root 5. So this becomes 12 times of 3 minus root 5 upon, this is a plus b into a minus b, so this becomes a square 9 minus root 5 square 5, which is 4. 9 minus 5 is 4 and 12 by 4 is 3. So this becomes 3 times of 3 minus root 5. Okay. And do we have an option like this, 3 into 3 minus root 5? Yes, option C is the right answer here. Thank you.